Welcome, everyone. Next, we have Dedaimia Kozlovsky from Mayo Clinic to talk about generative AI and FHIR in the Mayo Clinic cloud.
Hi, thank you for the introduction. I'm Dedaimia Kozlovsky. I'm a principal software engineer for Mayo Clinic, and I'm working primarily on Mayo Clinic Cloud, which is a 10-year strategic partnership between Mayo Clinic and Google to redefine how healthcare is delivered and accelerate the pace of healthcare innovation through digital technologies. That all sounds very fancy. I'll give you a little bit of detail in this presentation of what that means in the real world. So the first part of this is we've loaded a whole heck of a lot of data into Mayo Clinic Cloud, which is our Google Cloud presence. I'm not going to read you all the stats, and if you are interested in learning more about this data, my colleague Katie Bovey gave a more in-depth presentation on the data yesterday, and that'll be recorded. We do have 11 million patient records in our main FHIR store, which we also call the longitudinal patient record in Mayo Clinic Cloud. And that's available in multiple formats. So you can call FHIR APIs and get the data that way. The same data is available as a streaming subscription through Google Cloud PubSub. The same data is exported out to BigQuery in flattened tables. We're not using the SQL on FHIR specification that we had a presentation about earlier, but the same idea. It's out in BigQuery tables. You can write SQL queries against it. And then we also have tools like there's a self-service explorer called Mayo Data Explorer that will let you explore that same data without having to write SQL queries or FHIR queries at all. So all FHIR data, 11 million patient records, multiple modalities. What do we do with all that data? A lot of it is research use. We've got researchers going in there using it for cohort identification to pull the data they need to run their research studies. It is also used for clinical use. We've got an acute care multi-patient viewer that runs off the data in Mayo Clinic Cloud off that LPR FHIR store. We've been developing traditional AI models for years now. I helped with one a couple years ago for predicting 30-day readmissions, again, running off the data that's in the Mayo Clinic Cloud. And in the last couple of years, of course, the hot topic is generative AI, using that FHIR data to ground large language models. We did a call for interest for internal funding for some generative AI projects last year and had over 300 submissions from all sorts of different groups at Mayo. So this is research teams, this is clinical teams, this is IT teams. Everybody's interested in using generative AI and using generative AI on our patient data in FHIR. That is the main topic of this presentation. We don't have a lot of time, so I'm just going to give you a very high-level overview of 3 of those projects using generative AI on Mayo Clinic's FHIR data. So the first use case, this is just in the planning stages. We started talking about it a couple weeks ago. It is for that acute care multi-patient viewer. They're interested in showing a problem list. And you might say, well, you've got an EHR. There's a problem list in the EHR already. That's true. We have Epic. There's a problem list in Epic. But it is very high level. It's general. It's for the patient's entire history. The ICUs want a stay specific. What's the patient's problem for this admission today? What problems did they have yesterday? Have they gotten better? Have they gotten worse? I need to know, and I need to be able to know that quickly without reading 10, 20, 30, depending on how long they've been there, a lot more text notes. So we have the data. We've got problem lists typed into these notes. You've got to pull up the notes and read them to find it. That's where the generative AI comes in. So how are we going to do this use case? Well, the first step is to identify patients. Pretty easy in this case. We'll take all the patients who are admitted in a certain unit. We need to get the FHIR data for that. In this case, because we know it's all in clinical notes, we know which clinical notes, and we want to be able to update this close to real time. We're not going to make a FHIR call. We are going to subscribe to that streaming PubSub update and say, we want all clinical notes for these patients. Just give them to us as soon as they're put into FHIR. As the notes come in, if it's the first note for that patient, it'll get passed to an LLM. The LLM is instructed to summarize the problem list from that note. We'll probably give the LLM some examples of, here's the right way to do it. Here's an example note, right answer on that one to help ensure quality. We can give it hints on how to read our notes. Some of these notes have the problem list in a very defined format with #1, #2 prioritizing the problems. So LLM is asked to generate a summary. Then when the next note comes in, we pass the new note, the existing summary, and say, hey, LLM, update the problem list based on this new information that just came in. And it'll give us a new summary, take into account the new problems. Is there now a more severe problem that should be number one on the list? Has one of the previous problems resolved? And that means that at any moment we have the nice LLM curated summary problem list. The provider can just click on a little icon in the multi-patient viewer and see it. If they've got questions about any of the problems that they see there, or they're not quite sure the LLM did it right, it is going to provide citations back to the original notes so they can click and see the full note. You know, if it says the number one problem is we're concerned about infection at the surgical site, there's a good chance they're going to want to go and read the whole note and learn a little bit more about that. All right, so the second use case, this one's in development, close to going live, but not quite yet. Very similar process, you'll notice, but a different problem. This is we call this VITA in-house. I had to ask about 3 times what it actually stands for. The Virtual Interface for Discharge Assistance. And the idea here is it's complicated, discharging a patient. There's a whole lot of stuff that's got to get done before you can get him out the door. I'm not the expert. I'm an IT person. I'm not the expert at all the stuff that needs to get done. I'm sure there's other people in the room who know better than me, but it's things like, oh, we need to get certain labs done and make sure their measures are looking good. They need a clinical review before they leave. They might need medications. They might need instructions on care at home. We need to make sure somebody's coming to pick them up, that they have a ride home. A lot of things before they can walk out the door, and it's complicated to keep track of. So this one's a partnership between a traditional deterministic program and an LLM. The deterministic program has flow sheets, essentially, for what needs to happen before a patient with a particular condition in a particular unit can walk out the door. And it's using the LLM to determine which steps have been done. So again, we're identifying the patients of interest. They're being discharged soon from this unit. We'll query FHIR in this case. This is not run quite as often. We don't need up-to-the-minute data, so we're not going to use the streaming subscription for this one. We'll query FHIR for all the relevant resources. So this will be flow sheets in the observation resource, clinical notes and document reference FHIR resources, lab and pathology reports. And then pass that information to the LLM and say, has this step been done? Do we have this lab report that we need? Is the value good? Do they have a ride home? Has someone put in a note that their spouse is coming to collect them at 2 p.m.? And just get, all the LLM has to do is yes or no answers to these questions, and then again, provide the reference to the FHIR resource or the note from which it's answering that. That gets passed back to the deterministic system. The deterministic system says steps 1, 2, 3 are done. We suggest that you do step 4 next. That can be shown to the care provider to help figure out what they need to do. Again, without spending half an hour reading back through the medical record to find out what's already been done. And again, with citations, if the LLM says, why, yes, their spouse is coming to collect them at 2 p.m., we want to be able to link to the note, and they can read and confirm that it didn't say 2 a.m. and the LLM misunderstood it. All right, use case number, I'm trying to go to use case number 3. I'm having technical difficulties. There we go. Use case number 3 is a little bit more open-ended, and this is in production now. So the first 2 that I talked about are very discrete, narrow use cases. We want a problem list, we want a discharge summary. This is general purpose. We just want to let anybody who needs to ask a natural language question and get it answered from our FHIR store. So that's natural language FHIR search. We did not build this from scratch. We used a Google tool, and you'll see a little demo of that next. But if we were building it from scratch, the basic concept here is you take all your FHIR resources, you put them in some sort of searchable store. Typically for LLM use cases, this would be a vector store. The user types in a natural language query. We search on that store to find relevant records that are related to whatever they query about. Search returns a list of resources in ranked order from closest match to least relevant. You pass the top however many results you think are appropriate that you can afford to pass to the LLM along with the user's question and say, hey, LLM, answer the question using only these resources that I'm passing to you. Does reliably a very good job with that. and then display the answer back out. So the example I had in here is, what's the patient's cholesterol? It's going to run a search, find probably lab observations for cholesterol. Those will be the matching results, pass those to LLM, and it'll say, I have no idea if these cholesterol numbers make sense, by the way, not a clinician, so somebody mock me if those are bad made-up numbers. And again, with citations, so if you don't believe the LLM answer, you can go and read the observation yourself. So let me show you, this is just a quick 2-minute demo of this running. This is not Google's UI, nor the UI that's rolled out for clinical use. There's a much prettier UI for the physicians. This is just our test UI to give you a flavor of what it looks like. See if the audience can.
Demonstration of Google's new feature for natural language search on FHIR using Vertex AI search and conversation. So I'm showing here a very small FHIR store we made for testing with synthetic patients in it. All of this is generated by Cynthia. We've imported that into Vertex AI search and conversation, and we have a little test app here that lets us search that store. So I selected one of the test patients, and I can ask natural language questions about their record, like, let's ask about cholesterol. And that will search and find the relevant FHIR resources. In this case, they're all lab observations, and also give me a nice little summary answer to the question. We can ask about A1C instead of cholesterol, and it will do it just as well. One of the really exciting things about this is, in addition to the regular resource types, it will search on any documents that are in the patient's record. So in this case, we've uploaded a couple of sample notes. This one's text. This one is a scanned note. It's not even oriented right, and it will use optical character recognition and be able to read this. So I can ask about things like insurance. Let's find out if this patient's on Blue Cross. And sure enough, it finds that that is mentioned in that scanned document. Actually, the patient is covered by Blue Cross Blue Shield, and find that. And you can ask about pretty much any other facet of their medical record, like let's ask about medications as well. And it'll find that, in this case, again, it found that in the documents. We don't have a medication statement record for this patient. That's a quick overview of Vertex AI Healthcare Search.
So that one, again, is live in a limited pilot at the moment. We've got about 2,000 patient records from FHIR loaded into that for somewhere between 1 and 200 providers are trying it out. The initial feedback from them is very positive that this is able to save them a lot of time. The real UI that they use for this also lets them save their favorite questions. So they can say, I have 4 questions I want answered for any patient who walks in my door, and very quickly get answers to all of those from the medical record. We're very aggressively moving towards getting the entire 11 million patient records in our full FHIR store in there. And if you do want to learn more about the Google tool, Raquel Izquierdo from Google is here and is doing a much more in-depth presentation about it this afternoon. This slide, I just wanted to reiterate again. We're using the Google tool. It's easy. It's convenient. We're partnered with Google. It has awesome features like the OCR and some built-in knowledge of healthcare terminology, but you can certainly build something like this from scratch yourself. We actually had before Google came out with the healthcare tool, and then we abandoned it in favor of theirs. But you load the FHIR resources into a searchable store, you run a search, get back the relevant resources, and pass them to the LLM. It's really a very simple concept. All right, so I don't know if you noticed this, but I certainly did when I was typing up these slides. These use cases all have a lot in common as far as how we're implementing them. They're all retrieval augmented generation. We're retrieving records specific to a patient or an encounter. We're adding in some company or domain-specific knowledge, like how to read certain note types to find problems, what's our standard discharge flow, and then we're passing that internal knowledge to the LLM and saying, generate me an answer, generate me a summary, generate me annotated text, extract me some text based only on this content that we're passing in. We don't want you to answer it from the internet. We don't want you to make things up. Just use what I pass in. And we get really reliable, high-quality answers that way. I'm not going to say there are no hallucinations. There are always some level of hallucinations, but the grounded approach vastly reduces that. And then the other part, since LLMs still make mistakes occasionally, is there's always a human element. All of our use cases, the LLM is an assistant only. Humans are making the final decision. we ask the LLM to provide citations so that a human can check its work. I like to say we treat the LLMs kind of like a slightly dim intern, you know? You use them to do the grunt work, but check their work. All right, and then if you are interested in learning more about this, this is a very short session, so I've just provided some links to learn more about Mayo Clinic Cloud, generative AI, large language models, retrieval augmented generation, and the Google Vertex agent. And again, there is another session about that this afternoon. And I think that brings us to Q&A.
Hey, Vadim here. Thanks for a great talk. I was wondering about the citations. What happens if you don't find citations for everything that was generated by the LLM?
So that's an interesting question. There is another project at Mayo that I haven't included in here, that is the focus of their research, is they have the LLM generate an answer, and then they use another LLM to check its work and make sure that everything that's in the answer is actually from one of those citations, that it's not lying about it to us about citations. For the healthcare search, the Google tool, it does provide citations out of the box. I'm not going to lie with you. We've gone back and forth a few times on with Google on are we really getting citations for everything. We've definitely seen improvement as they continue to work on that tool. There's now an option where it used to be just automatic. They've now put in explicit options where you can say, yes, I need citations. By and large, when the citations are on there, we're relying on testing and human feedback to tell us if we're seeing exceptions to that on that tool, and we're getting very good feedback.
Okay, thanks.
Do you guys actually, when patients transfer from a different institution or different clinic, do you take all that data and stitch it together?
So not very well prior to this tool, but yes, when a patient comes in from another organization, we get usually faxed, sometimes hundreds of pages of records from those external institutions. If we're lucky, they come in discrete pieces, so we can say this is a lab from the external organization, this is a clinical note, but often they're not. It's just 200 pages of undifferentiated. And that's one of the reasons we do love the OCR capability in that FHIR search, is all of those scanned notes are in our FHIR. Well, there's a document reference for them in the FHIR store. The actual content is on cloud storage. They get pulled into this, they get OCR'd. So when you ask a question, all of that is available to the search as well. The one thing we are still working on with Google on that is right now, it doesn't give you the page number in the 200-page PDF, but they promise us it's coming.
So if you mentioned that Mayo Clinic already uses Epic. If the other clinic is also using Epic, do you actually pull from their Epic instance all the medical records?
I believe the feature you're talking about is Epic Care Everywhere. We do have that. The Care Everywhere documents are not in the FHIR store that we're using for this yet. It's on the roadmap.
Can you discuss a bit about the terminology support in Google? So for example, there are different line codes to refer to patient's cholesterol or eGFR values and things. Does it handle all those different line codes when you post that natural language query?
That one I'm actually going to refer to Raquel, if you don't mind. She's the expert on the Google tool.
Yeah, I mean, what we do first is that since you expand the query and you try to do query expansion and cover all the different terminologies or mentions of those different labs, the first step, as Dedaimia was mentioning, is retrieval. So you find all the observations within the FHIR resource, within the FHIR record that match those ones, and that is going to be fed as the input to the LLM. So we try to be as comprehensive as possible with slightly different names, terminologies, like capitalized, non-capitalized, and so on. So we retrieve everything that is relevant within the observations resource, and that is fed into the LLM. So even if you have structured data that belongs to different categories and are different entries, the LLM will be able to understand and take all of that as an input to give an answer. And even, as Dedaimia was mentioning, even if there's a mention of cholesterol lab that is not really in the observation resource, but rather mentioned in a document, in a note, or even in a scan document, then you're also able to retrieve that. And because that is all fed together to the LLM, then it will be able to process all of that information more like structured and unstructured and give you an answer based on that.
Hi. You mentioned that when you're doing the summarization, it's pub sub, and then you're passing it the old summary plus the new resource. Did you find like it's better when it's additive rather than reductive, like taking all the resources at once and trying to generate a summary?
So for that use case, if a patient's been in the hospital for more than a couple days, there's going to be more notes than we can pass to an LLM, even with a really large context window, and the context windows are getting larger in one go. So we would have to do some sort of map reduce anyway, because in that use case, we want it really up to date. It's just convenient to do it where we add each note as it comes in and say, add on to the summary. If we didn't have that urgency, if we only wanted to run this once a day, we probably would pull all the notes, chunk them up into small enough pieces to pass to the LLM, summarize each piece, combine the summaries, tell it to summarize it again until it's a small enough single problem list.
Okay, so if you were building it like first run through, you
Right.
would pull as much as you could.
Right. But in this case, we're going to start running it as soon as the patient is admitted. So we just run the notes through as they come in.
Was there a question back here? I think you had your, yeah, thank you.
Hi, thank you. I love the method, really love the LLM only for summarizing, really smart. One question is, how do you handle the privacy data? So, because you have full data in the whole database, and then you use LLM on the cloud. So how do you handle that, ensure that this data doesn't filter in the other models, and how do you ensure that all the people who have access to this data as the right people?
So all of the use cases that I presented today are internal clinical use cases. The providers using the LLM tools have direct access to the data. We're not adding any data access here. The users can see this already. As far as protecting the privacy of our healthcare data on Google Cloud, generally we're using Google Cloud IAM permissions management to guard that. We also use virtual private cloud networking constraints to ensure that that can only be called from other places within our cloud presence or from our on-prem resources, not from anywhere else on the internet. And then for the last part, the privacy of the data that's being passed to the LLM, that is part of Google's standard contract, and we're very careful, a lot of contract negotiation there to be absolutely sure when we call an LLM in our project, in our VPC perimeter, that that data is not going back and feeding into LLM training.
Okay, thank you.
You just mentioned the pub/sub. What's the framework or technology you're using for that?
That's actually part of the LPR Firestore is in Google,
Google,
Cloud
okay.
Healthcare, and that is a feature of Cloud Healthcare that you can turn on a pub subtopic and get streaming updates from that Firestore.
Okay. Another question is, do you have any data that not the FHIR data? Or
Yeah, we're using the same method with quite a lot of non-healthcare data. It's just this is a FHIR conference, so I'm talking about the patient data, but very similar projects using our internal policy documents, using our IT knowledge base to help people get easier answers on their IT questions. On our nursing procedures, there's a ton of other similar projects running, and all following very similar retrieval augmented generation patterns.
okay, thanks.
One more question?
Thanks for the presentation. Very interesting use cases. I just wanted to ask you if you guys have ever played around with generating FHIR resources. So kind of the flip side, going from LLM to FHIR.
I can't speak for everyone at Mayo. We have an enormous community doing this. I have not personally done that, but yeah, this conference gave me some ideas that we should be doing that. A lot of our FHIR mapping from HL7 from on-prem databases is to FHIR is done at this point, but I think certainly having an LLM assist with that the next time it comes up is something we want to look at.
Okay, I think we're out of time, so thank you very much.